Okay, we're going to start looking at solving systems of equations algebraically. So in the previous video, we were looking at the graphical solution of systems of equations. And remember, there's three types of solutions we can get. We can get one solution. That's where we know exactly where x and y are, where the two lines cross each other. There's no solutions, which means the lines never cross each other. They're parallel lines. Or there's infinitely many solutions, which means that the lines are literally the same line. They're right on top of each other. And so any point that I choose for one is going to be a point for another. So that's just kind of a very quick verbal review of those types of solutions. If you need a little bit more, go back to that video called Types of Solutions so you can actually see kind of the whole video there. So there are a few ways to solve systems of equations algebraically. We will begin with what's called substitution. Substitution is the process of replacing one value with another that is known to be equal. That should say equal. I'll fix that. So this shouldn't say value. This should say equal. We are given an equation equal to a variable, so we can use the substitution method so that only one variable is present and the system can be solved. Because we can't really solve y equals x minus 13. I need to know what either x or y is in order to solve this. So when we're given something like this, this is kind of the very beginning of substitution. So we have y equals x minus 13 and y equals 16. So let's kind of think over here for a minute. So y is equal to x minus 13, and it is also equal to 6. They're telling me what y is equal to in both situations. 16, sorry, not 6. So I know y is equal to 16 already. Yay, I already have y. But I need to know up here, x minus 13, I'm going to have to plug that in and kind of figure that out. So x minus 13 and 16 must also be equal. I can kind of get rid of the middleman here instead of saying, y is equal to x minus 13 and y is equal to 16 instead of using the y. If they're both equal to y, they must both be equal to each other. That's what equal means. So I can just substitute them together and say, well, x minus 13 equals 16 instead of having those y's in there. So now I can just solve this equation so I can figure out what x is. So I'm going to add 13 to both sides to undo that subtraction. So x drops down, 13 minus 13 cancels out. Any time we have a number minus itself, it's going to be 0. And then 16 plus 13 is 29. I don't have to go back and plug in anything to find y. I already know y is 16. So we don't have to go back and kind of rework that one. So again, this is kind of the very basic idea here. Now we're going to go to a different one. Oh, first we can check really quick. So we already know that y equals 16, but we can check it anyways. So if I just go back and I check this really quick, and I say 29 minus 13 better equals 16, that's just going backwards on this one. So as long as we kind of go back and forth with the numbers, we should be good to go. So this is a very simple kind of check idea. All right, so this one is a little different. We're not given y equals on this one. So we're given negative 2x plus y equals 1, 3x plus 5y equals 18. So first, we can solve that first equation for y super, super easy, right? All I have to do is add 2x to both sides, and then y is going to be all by itself. So you want to choose, in this case it's y, but if by chance x was the easy one to solve for x, okay? So solve for the one that's easier. In this case it's y. So I'm going to take this equation, and just like I said, I'm going to take that negative 2x, and I'm going to add it to both sides because this guy is going to cancel. Negative 2x plus 2x is 0. Y drops down by itself, and then I have 2x plus 1. So keep in mind here that I did not combine the 1 and the 2 because 2 is being multiplied by x and 1 is not. So I keep them separate like this. So now I do know what y equals. Y equals 2x plus 1. So now I can substitute in this equation. Since I know that y equals 2x plus 1, I can take here and I can change this y into 2x plus 1. It's called substitution. I know y equals 2x plus 1, so I can replace it. So down here I have 3x plus 5 instead of y. I've replaced it with 2x plus 1 equals 18. So now I'm going to go through and I'm going to start to simplify this. So I'm going to distribute that 5, so I'm going to multiply by 5. So I get 3x because that just drops down. 5 times 2x is 10x. 5 times 1, I need to move that arrow over a little bit, but 5 times 1 is 5, equals 18 just drops down. That does not get multiplied. That's not inside the parentheses. It's not even on the same side as the parentheses. So it gets moved over there. All right, so now we can combine like terms. So we're still simplifying before we're solving. So 3x plus 10x, we get 13x. The plus 5 and the equals 18 just come down because they don't have anything to combine with yet. Not on the same side as the equal sign. Okay, so now I can start to solve this two-step equation. We've gotten it down to 2 steps. I'm going to add or subtract what's being added. I'm going to do the opposite of what's being added or subtracted on the same side as the variable. So since 5 is being added, I'm going to subtract it. 13x is going to drop down. The 5's cancel. 5 minus 5 is 0. 18 minus 5 is 13. So now my last step is to undo the multiplication that's happening here. So I'm going to divide by 13 on both sides. 13 divided by 13 is 1. It's the same thing on this side. 13 divided by 13 is 1. I don't have to write 1x. I can just write x equals 1. So we just automatically assume that if we see a variable with no number in front of it, it's automatically a 1 in front of that number, or in front of that variable. Okay, so now we have x. In the last one, I didn't have to go back and solve for y because we already knew y equaled 16 on that first one. Well, in this one, I don't know specifically what y equals. I know it's 2x plus 1, but I don't actually know what it is yet. So I'm going to go back and I'm going to use this equation because this is a little simpler. You can use either one of these two. It really doesn't matter. Or you can use this one that you changed. So I'm just going to go through and I'm going to plug in 1 for x. So it's 2x plus 1. So I'm putting x in here now. So I'm substituting again, technically. So 2 plus 1 is 3. So now I know what my solution is. My solution is 1, 3. And remember, this is a coordinate. 1, 3. So what does that look like? Because that's definitely something easy. And this is a program called Desmos.com. If you've never used it before, it's super easy. You can type in your equation and it will automatically graph your line for you. So negative 2x plus y equals 1. And then we have 3x plus 5y equals 18. And we can see here is our solution, which is 1, 3. That's the point at which the red and the blue line there cross. It's also got these little gray dots. Those are the intercepts. It just automatically highlights those on Desmos for you for the last equation that you have highlighted. It's doing it for the blue line because you can see I haven't clicked on it. If I were clicked on the red one, it would be showing me the intercepts for the red one. All right, so that was solving a system of equations algebraically using some substitution. So I hope that helped, and I'll see you in the next video.